Good afternoon, everyone, and welcome to the video lab for Bio 168 on the physiology of the eye. By now, you should have watched the dissection of the bovine eye, and you should have also seen the video of the review of the human eye model. So now we're going to go over the physiology of the eye, and we're going to use the lab manual as well as our supplemental sheet with the supplemental exercises here. And we're going to talk first about the visual acuity test. And the visual acuity test, as you've probably seen many times in your doctor's office, is simply the eye chart. So you stand at 20 feet and you read the smallest line that you can see. Now, one of the things that you'll notice about this chart is the lines get progressively smaller and smaller, and you'll see these numbers off to the side here, like 2050, 2040, 2030, 2020, and 2015, and so forth. So what do these numbers mean? Basically, you are standing at 20 feet from the chart. So the top number is 20 feet. And you read the line that is the smallest that you can read. So let's say the smallest line you can read is 2050 over here. So that means you're standing at 20 feet. Your eye can see at 20 feet what the normal eye could see at 50 feet. So the top number is where you're standing and what you're able to see. And the bottom number is what the normal, what we call an emmetropic eye, is able to see. So the very top line, the giant E up here, is basically 2200. So that means someone who would have to stand at 20 feet to see that is fairly nearsighted, what we call myopic. And the normal eye would be able to see that clearly at 200 feet. Now, if you have very good vision and you're standing 20 feet away and you can read this bottom line, you see that it says 2015. What that means is you can see what 20 feet, what the normal emmetropic eye has to be at 15 feet to see. So the top number is your vision, your visual acuity, and the bottom number is the normal visual acuity. So 20 over 20 is normal vision. 20/20 means you can see at 20 feet what the normal emmetropic eye can see at 20 feet. Likewise, 20/70, if this was the smallest line you could read, that means you could see at 20 feet what the normal emmetropic eye could see at 70 feet. And if you have very good vision, some charts actually go down to 2010, this one does not. But if you had a line that was 2010 and you were able to read it, that means you can see at 20 feet what the normal emmetropic eye would see at 10 feet. So that's how the eye chart works, and that is the visual acuity test. Next, we're going to talk about the astigmatism test. So next is the astigmatism test, and the astigmatism test checks for any kind of defects in your cornea or your lens, and these are the clear parts of the eye through which light is refracted. And just like a lens, a ground lens in a camera, the grinding has to be perfect to get a perfect lens shape that allows the light to be refracted to its convergence. So the point of convergence, which you've learned about in class, so that all the light falls on that point of convergence. If it doesn't, if you have a defect in the lens, then you'll get some waviness in the lines. So a lot of times, most humans, most of us, don't have perfectly lenticular shaped lenses, and our corneas may have some kind of imperfection in them. And so this test, and we don't actually have the chart in this lab, but you do in your book, you see this, basically these 12 spokes made of 3 lines each, and you look where they converge at that white spot in the center. And you look there, and you stand 20 feet away from it, and then you report if any of those lines appear wavy to you. That is, if any of the 3 spokes look wavy, it means you have an astigmatism where the light isn't quite refracted exactly correctly back to the fovea of your eye. And so this is an astigmatism test, and it shows that you're going to have some kind of imperfection or waviness or distortion in your vision. And once again, the test is simply to look at that center circle that's defined by the edges of those radial spokes there at the center. And if any one of those spokes, if any of the 3 lines in those spokes appears wavy, then you have an imperfection in that part of your vision. This is the blind spot test, which is very simple. Basically, as you've learned, the retina, the retinal ganglion cells, which receive input from the bipolar cells, which received input from your photoreceptors, the retinal ganglion cells all converge at the optic disc. And this is an area where you have no photoreceptors, because the axons from the retinal ganglion cells will then turn and exit the eye through the back of the eye as the optic nerve. So this test will map the spot where the optic disc exists. And you can only do this with one eye open, because if you look at it with both eyes, you're engaging your binocular vision. So what you do is you close one eye and you stare at one of the objects there, either the circle or the square or the X, depending on which one it is, and you look at it, and at a certain distance, one of those objects will disappear. But you have to keep your eye fixed on one of the fixation points, either the circle or the cross. And you have to keep your vision fixed there, that one eye, and then move towards or away from the chart until the other object disappears, and that will tell you pretty much where your optic disc is in the other eye. So that's simply, in the eye that you're viewing it with. So that's simply to show you where your blind spot is or where the optic disc is in your eye. All right, here we have the binocular vision test. And basically, your dominant eye will align your images. So these two pencils I have lined up, so the green pencil is in front of the black pen, or whatever this is. And what you'll notice is you have a dominant eye, and each eye, their eyes are spaced slightly apart by several centimeters. So what will happen is you are able to construct two separate images and combine them into one, and that gives you a depth of field. That allows you to judge depth. So if you close one eye, then you should see both these pencils aligned. But if you close the other eye and open the one that was closed, you'll see that now the two pencils are no longer aligned. That one is to the side of the other, depending on which eye you used. They'll either be this way or this way. And usually the vision that you see binocularly is more or less what you would see if your dominant eye had these two things aligned. But once you switch eyes, then they will no longer be aligned. And so that is a demonstration of the binocular vision test. And then we have one other interesting thing to show about the binocular vision test. And I will go get a test tube or a piece of glass here to help us demonstrate this. And here we have a test tube. Now I can't really do this myself very easily because I have good proprioception, and I can sit here and probably figure out where to put that from proprioceptive cues. But if I were to use visual cues alone, then what we would need to do is have a partner hold this for me, and I would attempt to hold the pencil, and first just stick the pencil in there. Easy enough. But now I close one eye, now move the test tube somewhere so I don't have the same proprioceptive cues, and now with just one eye I try to put the pencil in the test tube. First attempt didn't work out at all. So now I'll move over here. I'll use the other eye. And see, I can't do it because I have no depth perception. So I was using completely proprioceptive cues the first time I did it. When I put both eyes open, it's much, much easier to put it in there because you can't tell exactly where it is in front of you with just one eye because you have no depth perception. So that is the binocular vision test. Alright, so now we have the depth perception test. And if you look at this thing, you'll see there are two arrows that are lined up on one another, and this little scale you can read here, and this little background piece of paper here, this background piece of cardboard. So we can use both a white background and a black background, either way. And our job is to align the arrows. So if you step back here, you'll see these little curtain rod things we've got here. And I always tell people don't hold it by the ends because that will give you a proprioceptive cue or give you some kind of haptic cue. So you are to look at these and align them completely on the basis of your vision. And you kneel in front of it like this to get eye level with it. And you have your partner mess it up. So when you're not looking, the partner will do all kinds of crazy things with it. And then it's your job to make the arrows point right at one another. And so with binocular vision, I'm like 0.5 millimeter off. and I can do it. Plus, I also was the one who messed it up. That makes it a little easier. But, so you can see that I did pretty well aligning the arrows there, about 1/2 millimeter off. So now what I'm going to do is I'm going to screw it up again, and I'm going to try and align it with just one eye. This makes it much more difficult. Now I'm thinking to do this, and now I can't tell where in the world those things are. So I'll just put it like that, and I'll come over here, and I'm a couple of millimeters off. I'm 2 millimeters off. Call that luck, partially because I was the one who messed it up, but if your partner does it and you're not looking, I've seen people be 2 centimeters, 3 centimeters off. And it depends on, you know, how lucky you are or not. You can base it on some cues, like how much space appears to be in here. But in general, most people will be much, much worse aligning these arrows with one eye open than if they have both eyes working properly and have binocular vision. I find it easier against the black background because there's more contrast. A lot of people actually find it easier with the white background. For me, not so much. So I'll screw it up again, and then I can do the same thing and try with my binocular vision to align these, and that looks about right. Yeah, actually, I'm a little bit closer than I was the first time. And so now I'll do it again, mess it up again. Also, probably a lot depends on the time of day, too. All right, so now I'll do it with one eye, and you can do it with both. You try each eye separately, so now I'll use my opposite eye and try again. Let's see how close I get. And now I'm a good 1/2 centimeter off. And typically, when you have binocular vision, you're able to do this much more accurately. So this is the binocular vision test. So finally, we have the field of vision test. And basically, we're following the activity 7 on the sheet. And we have this little thing right here, this apparatus. And as you can see, it's meant to be placed at your forehead. And you have this tab right here. That is your fixation point. And you keep your eyes fixed there. And you have this little arm that swings around, and you have this degree scale up here. Now we have put in a card that has some letters on it. And there are 2 things that we're going to test. On each eye, we're going to test, first of all, what our peripheral most, where we can see this most peripherally. So if we're staring at that little fixation point, then our partner is going to bring this until we see it poke into it, the periphery, and then we look, and I can see that my peripheral vision starts at about 105 over here, 107, somewhere around in there, and we do that for both eyes. And that is just the peripheral vision. That tells us when something has come into our periphery. Now, then we keep moving it. Once we've established that, we keep moving it until we can see it. We can actually read the letters. Now, there are several ways that we do this. First of all, we are going to make sure the person is not looking away from this fixation point, because you're supposed to see right when that thing comes into your periphery. And then you do the same thing again, but you bring the arm all the way around until they can actually read what's on the card. And this is important because you have your peripheral vision, which is very blurry and pixelated. You have large receptive fields there, mostly rods, which are specialized for movement and shading, no color. And so you don't really see things clearly there. But remember that anything in your periphery that moves will catch your attention, and a lot of times it might even initiate one of your reflex arcs where the superior colliculus is involved. It'll make you look towards the object to see what it is and foveate it to the central part of your eye, the fovea centralis, where you have the greatest accumulation of cones, which see very sharply in color, but they're only activated by fairly bright light. But you have your highest acuity vision there. You can see best there. So this is what your collicular reflexes are for, so that you look and see whatever it was in your periphery that caught your attention, so that you can then look at it and identify what it is. And you really can't identify things that easily until they're in a field of vision that is closer to that fovea centralis, where you have more cones, you have smaller receptive fields, and you have the ability then to read what's actually on here. So most people will report seeing the letters somewhere in this range. So somewhere between, for some people it's all the way up to 30. So I can barely start to notice it around 50, 45, and some people report here 30 before they can even read the letters. Honestly, some people will cheat and they'll actually move their eye over in that direction without meaning to. So that's one of the bugaboos of this test. The other bugaboo of this test is a lot of people don't want to put this up to their forehead, so they hold it a few centimeters away, and that actually makes the scale here a little bit off. But typically, if you hold it correctly to your forehead and do the test, then most people will report peripheral vision somewhere between 90 and 100 degrees, and they'll usually start to see the letters around 30 degrees. So that is the peripheral vision test. And notice another interesting thing, when you're out here, you're outside your binocular field of vision. When you come to the center, now you're within the binocular field of vision as well. So that's just another aside, but the field of vision test tests first at what point you can see the object come into the periphery, and then at what point you can actually make out what the object is.